Hello friends, this is Dr. K.G. Revatkar from Dr. Ambedkar College, Diksha Bhumi, Nagpur. As you can see, the monument known as Diksha Bhumi, wherein Dr. Babasaheb Ambedkar has embraced Buddhism. So my college is adjacent to this monument. So I welcome you all again, once again on my new video on nanotechnology. Today I am going to talk about the basics of nanotechnology and how this nanotechnology has changed the world. So that I will explain you in my subsequent videos. So I will start with the nanotechnology, presentation on nanotechnology. So now let us understand and appreciate the word nano. Nano means it's a Greek word that is meaning as a dwarf. Now if we compare the atomic size and the nanometer, then something we can say that 1 nanometer is about 3 atoms long, or on a scale the nanometer can be defined as 1 billionth of a meter, that is 10 to the power minus of 9 meter. So now this nano is not a new word for Indians. Maybe some 700 800 years back, if you see, then there are Ajanta and Ellora caves wherein they have used a beautiful painting. Still the colors are prominent, and that we can see, and that is because they have make use of the nanomaterials. Now if you go long back to BC, then in Syria there is a place called as a Damascus, where they used to have the sword, and that sword was coated with a kind of the carbon powder, and that sword was very sharp and very hard to get it. So that time the nanotechnology was there, but the people were not aware about what are the properties. So now today we can have the technology by which we can find out that whether the material belongs to a nanomaterial or not. So that is a same and same technology, same and same technique that has made us uh, to get into the size of the particles. So now this nano word itself is a new application, and that is a non-believable origin. So now this non-believable origin means, as we you can see here, the atomic size motors we can do have, and there are different kind of the applications of the nanomaterial. So before that I would like to show you one a small video clip wherein there are certain properties of the nanometer that has been explained very beautifully. So one of the properties of nanomaterial, that is what we can say, that is a hydrophobic property, wherein it do not allow any water to get absorbed into it, or any liquid to get soak or absorb. So as you can see, the two screws are there. One is coated with the nano paint and the another one is not coated. So it is a normal. So you can see the oil that will be sticking to that. Even work gloves with the water. So you can say, you can check, one is coated with the nano powder and the another one is not coated with the nano powder. So we can easily differentiate between the two kind of the gloves. So this one is not untreated, you can say that the other one is a treated one. So likewise there are different examples. Yes, of course it is been pulled inside the mud. So we can see here the mud also sticking, so with the oil and etc. So likewise, so this is how that will be happening. The oil doesn't stick to it. Then again one is a treated one and another one is untreated one. So this is untreated one, so that mud has struck into it. So likewise this is one of the properties that a nanomaterial do have. So likewise, let me tell you that these two mouse, yeah, rodent, we can say that one is been not treated with the grains that has been coated with the fluorescent powder, but this mouse or the rodent has ate some grains which has been coated with the fluorescent, so that can be easily detected out. So likewise, maybe in another 5 years or 7 years we do have bananas with the taste of a fish, or a fish with the banana taste. So that is possible because we can work at the DNA level. So the same is the case with the orange and the apple, then tomato and the sweet lime, Then this is a kiwi fruit, and then fish and apple, something like that, and the chicken, you may say, or a cow which can produce large amount of the milk, or maybe this is possible that a dog can have appearance of a human being. Okay, so actually nanotechnology research focus and the key concept is mostly the nanotechnology or the nanoscience that has been divided into few parts, which is useful for the human beings. One, we can say that is a nano material, or nanosynthesis or nano process. We can see that, we can see in detail later on. The another one is the structure related with that, chemistry or the materials, how that we can explore this material. Then third one is the nano devices and nano electronics, as we are already enjoying the fruit of the nanoscience. One of the best example is your pen drive. So then nanomedicine and nanobiotechnology. If you see about the nano process, then because there are different kind of the processes by which the nanomaterial can be designed, and there are different kind of the approach. In a subsequent slide we'll come across with the different kind of the approaches the nanomaterial do have. Then about the chemistry, so it is very important that once we know the structure of the material, so that will be helpful to find out the what kind of the material we require, because the different applications required meant is different. So different kind of the materials do we require. The nano composite, then sol gel, quasi-crystals, and then quantum dots, and then the tube and rod and fiber and fluorine, etc. In nanomedicine, we can work at a biomolecular and biometric mimetic devices, biosensor, molecular motor, biomolecular fabrics, engineered enzymes and proteins. Yes, we can do. And also one of the application is to deliver a drug at a particular part in the body. Similarly, the nanoelectric and nanoelectronics and nano devices, we have nanotransistor, names, pebbles, molecular electronics, and nanoscale magnetics, etc. So now then, exactly what we understand the meaning of. So what is nano? So let me quote you an example, very simple example. If we consider, if you want to compare what exactly the nano is, something about our length or dimension wise, a normal person can walk 32 kilometers or about 20 miles in a day. If a person starts from morning till evening, so from 6 a.m. to 6 p.m. we can consider in general, then a person can walk about 32 kilometers. If a person were shrunk, so that shrunk to the size of 1 nanometer tall, so the person normally we can consider 5 feet 5 inch or 6 feet person. If we shrunk that person to a size of 1 nanometer, how long would it take them to walk a length of a 10 rupees note? So Indian 10 rupees note if we consider, and if we place that 1 nanometer size long tall person on the one edge of the one corner or the one side of the 10 rupees note, then to cross the total length of the 10 rupees note from one corner to the other corner, how long it will take? You may guess a while, but it will be, yes, 24 years, 1 nanometer tall person. That means you just imagine that how small a nanometer is. As I already told you, that few molecules comes together and form a nano molecule. So we are talking, or we are working, nano science or nanotechnology is at the atomic level. So now, just to get a rough idea about nanometer scale or nano size, so to know that how exactly we can find out the nanometer, that how long. So we can start with the centimeter. A centimeter is about something the size of a bean, normal bean we can consider. Now then we can divide that bean into 10 equal parts. So each part is a millimeter. So 1 centimeter divided into 10. So 1 division is 1 millimeter about the size of a flea. Now again we can divide that 1 millimeter into 10. So 1 upon 10. So that is then 1/10 of a millimeter is something about, you can say that is 100 micrometer long. 1 micrometer 10 to the power minus of 6 of meter, about the size or the width of the human hair. Now again we divide that human hair, the 1 micron meter by 100. So then each part is a micrometer long. So 100 will be one part, if we consider 1 micrometer long, about the size of a bacteria. And now we divide that into 10 equal parts. Then each part is about 100 nanometer long, about the size of a virus. And now again if we divide that into 100 equal parts, so the one part is something is about 1 nanometer, about the size of a few atoms or molecules to come together. So we started with a 1 centimeter, and then we subsequently divided into small part. So finally we come that is about 1 by 10 to the power 9 of meter. So each part 1 by 10 to the power 9 meter, so is a you can say that is a nanometer, is about the size of few molecules come together, and that will form a 1 nanometer. So now the size matters a lot. If we consider the gold, as we already know about the gold, that at a bulk level, if you consider a bulk level means a lump, then it appears to be yellow color. But if we divide this gold particle into a small size, small parts, small keep on dividing into crushing into, then if we come something about a 2 nanometer size, a gold 2 nanometer size, then it will appear a blue. Yes, gold can appear like a blue color. And if we consider about 2.98 nanometer, then something we say is a green color, then the purple color, then yellow color, and 7.9 nanometer if you consider it, then it is about the red color. So 12 nanometer gold particle look something like to be red in color. So why this is so is because of the size dependent property. The surface to volume ratio, I have not included that particular slide here, but you just see that as we go on reducing the size, what will be happening over here. So one atom, the size will be different. 19 atoms, then size will be different. As the number of atoms, that will be increasing, but you can see how much area they are occupying, and the size in the diameter you can see, then the surface to volume ratio, that will be increasing in case of a nanomaterial. So likewise, when we reduces the size of the particles to a nano size, then the optical properties of the material, that will be changed. Ordinary light excites all color quantum dots. So any light source bluer than the dot of the interest work, then quantum dot change color with the size, because the additional energy is required to confine the excitation to a small volume. So as you can see, the size that will be reduced down, the color that will be changing. So from red to violet, if you compare the size wise, then that something will be there. Here also I told you that if you consider this size to this size, then as the size increases, the color that will be changing. So now if the bulk metal is made thinner and thinner, if we consider a three-dimensional material thinner and thinner, and if we draw a graph between the energy and the density of states, then until the electrons can move only in two-dimensional instead of three-dimensional, so we reduce from three-dimension to two-dimension. That means we consider a bulk or a lump, and then we reduce, keep on doing the thinning and thinning, reducing the size, so we can have a piece of a paper like that, like a writing piece of the paper. Then we confine, the quantum confinement will be a two-dimensional. Then you can see here, in that case, the energy density earlier it was almost, you can say that the graph is going like this, but here due to two dimension, the graph that will density of state that will be changing with the energy. So here it is a smooth curve, here it is a stepwise. Now again we reduce the next level, we can say that is a quantum wire. So thin sheet that will be reduced into a form of a wire, so that it has only one dimension, either a length we can consider. So in earlier case two dimension we had the length and the breadth, and now in the three dimension we had length, then we are breadth, and we have this thickness also we can consider. Now in this case we consider a wire, then the density of state that will be changing. So you can see here comparatively from a smooth graph to a stepwise to again the peak wise, the sharp peaks they are observed. And again if we reduce the one dimensional wire into a quantum dot, that means it has almost no dimension. So from 3 dimension to 0 dimension, then you can see here wherever the particles are there, the energy is something like a spike or something like a one line dot that will be there. So now what is so special about the particles? That is, if we consider a bulk material and a nanomaterial reduced down. So let me explain you with this with an example of a square block I can consider, which is having 1 meter by 1 meter by 1 meter. If I consider now, then in that case, if I try to find out the surface area, then any cube has 6 surface, 1, 2, 3, then the 4, 5, and the bottom one is a 6 surface. So 1 meter into 1 meter, 1 meter square, and 6 spaces, 6 meter square is there. Now what I do, I can cut this cube into two pieces, and then again into like that. So into 4 pieces, 1, 2, 3, 4. So I cut like this and I cut like this. So 2 cut I had given, one is vertical one and another one is horizontal one. So now then we got the cube of a smaller size. So each cube, so 1 meter cube, so it will be divided into, so 0.5 meter into 0.5 meter. So likewise, when you calculate, because each cube has a 6 faces, so 0.5 into 0.5, 0.25 meter square, and if you add like this all the 8, then it is we are getting a 12 meter square surface area. Now again I divide into 4 parts, 1, 2, 3, 4, 1, 2, 3, 4. So there are large number of the cubes that we have divided, but ultimately if you see the surface area that has been increased, so each cube will be of 0.25 meter. So total surface area if you calculate of 25 meter, so this is 4 into 4, 8 fours. So like this, then there will be something like that, 1, 2, 3, 4, 4 fours are 8, 8 fours are 32. So 32 cubes are there. So surface area that has been increased. The volume that has been kept, so 1 meter into 1 meter into 1 meter. So volume is 1 meter cube. But because the size that has been reduced down, so the surface area that has been increased. So this I can this will be better understood with the help of this small video. Yeah, you can see here. So 3 jars that has been taken, and different size the calcium carbonate that has been taken in a 3 yes, and it is water, this one, and this one. So you can see here the size. Yeah, the lumps are there, powder, then smaller size and bigger lumps are there. So he will be adding one by one, so you can check. So what will happen when the surface area that will be increased or more surface area, we find that the more lump added, so that still they are not dissolved into it because the smaller area, but still the reaction that will be going on. Now then a little smaller size, the 2 lumps that will be divided into some 6-7 lumps when they are added into it. So little more rigorous reaction you can check over here. So they are seen at the bottoms, but not that much of the, and now when the powder is added, you can see here the difference, because all the particles come in contact with the liquid, so more rigorous reaction, chemical reaction that will be taking place because the number of particles are more. So this is what will happening. So in case of a nanomaterial, the same nanomaterial, but because the size that has been increased, the surface to volume ratio that has been changed, and all the properties of nanomaterial that will be due to the surface to volume ratio. So now in general the nano world or nano will be divided into two parts. One is called as a nanoscience, the another one is called as a nano technology, where in a nanoscience where researchers learn about the chemical and physical properties of the material at the 1 to 100 nanometer. Yes, here at this point I would like to tell you that what particular material we can consider to be a nanomaterial. So in that case, a standard definition of a nanomaterial is that a particle having any one of the dimension, even if it is in a three-dimensional particle or crystalline material, then any one of the dimension is 1 to will be falling in the range of the 1 to 100 nanometer, then we can say that it is a nanomaterial. So nanoscience, the study of physical and chemical property, materials at 1 to 100 nanometer are called nanostructure, and they are smallest thing that can be made. And nanotechnology, where researchers develop and apply the material at the scale to develop new product and methods, that is turning nanostructure into usable tools and applications. So application part we put into a nanotechnology, nano engineering you can say, and the basics, the study about the physical and the chemical properties or its mechanical property, optical property, so that we considered into a nanoscience. So the nanomaterial has a nanoscale. If you see, then they have a unique property which is not seen in the. So one is the intermolecular forces, and because of that we can have the stickiness. The shaky thermal energy is also there. They are susceptible to a thermal energy. Then bumpy, because of the quantum effect, quantum dot, they can have the bumpy effect. So the same we carry on. Yeah, this is the example of the nanomaterial coating. So nanotechnology involves the manufacturing and application of instrument and the materials that have unique properties because of their small size. At the nanoscale, properties of the material behave differently and said to behave under atomic and molecular rules. So atomic and molecular, because we are directly going to their level. So unique properties of material, that is small scale, to create new and exciting tool and products in all areas of science and engineering, that is possible. So let me explain with the, yes, in a nature the nanoscience is already there and we can do some biomimicry of nanomaterials also. So scientists are trying to mimic the nature so that they can find out some application. The sticky feeds. Now as you can see, different kind of lizards feeds are shown. So this if you see the bottom side of the feed, then they are having something like this frill structure, frill nature, where a large number of the nano fibers are there. So because of that they can have the stickiness, sticky feeds. Then strong spider silk. Yes, you can see, we know that we can also do the mimicry of the spider, and we can prepare a silk fiber so that it will be strong like the spider web. Then self-cleaning or reflecting butterfly wings. Yes, the water do not stick. The hydrophobic property, so already materials have been developed. So this is already existing in nature. The moth or the butterfly, you can see having the wings coated with the nanomaterial, so the water do not stick. So then optical nanoscience. Yes, different colors that will be reflected because of the nano. Then water collecting beetle bags, so that water can be collected on the back of the beetle also, that is already there. Then tough and light token beaks. So this particular bird has a very tough but very lighter beak is there. So the carbons are developed in such a way that they are lighter in weight, but they are very strong or tough. And there are so many lists are there, so many uh, things which are occurring in the nature, so which can be biomimic into it. So now then, in general the nanomaterial synthesis method will be broadly divided into three parts: the physical method, chemical method, and again Nowadays green synthesis, that is been people are working into it, because some of the chemical methods are very dangerous for the human health. So people are trying to get some green synthesis method with the help of a biological method. The physical method will be divided into different methods are there. So mechanical method, then vapor method, then mechanical milling, then physical vapor deposition, then again PVD method, that is called as sputtering, laser ablation and laser pyrolysis. In chemical method, sol gel or sol gel autocombustion method, wet chemical method, spray pyrolysis, colloidal method, chemical vapor deposition also there. And in a green synthesis method, we can make use of some part of the plant's stem, leaves, latex, flower, seeds, or some kind of the bacteria, fungal or yeast that can also be used for the synthesis of the material. So now there are two approaches till date the people are observed. One is called as a top down approach, in which mostly the physical method of the synthesis are there. So the big or the bulk material that can be cut away into a small pieces. So we can go from a big size material, then we can reduce into a small particle. So there are different kind of the physical methods, as I spoke in an earlier slide. Now, and there is another approach that is called as a chemical approach, or bottom up and top down. So from big size to small size, and from small size, small atom to atom, we can develop a big or a required nanomaterial. So likewise, building what you want by assembling it from a building block such as atom and molecule. So atom by atom or molecule by molecule, or sometime a cluster by cluster. So cluster is a group of some molecules or atoms come together, so that will form a nanomaterial. So now this metallic nanoparticle synthesis, as I told you, there are two approaches: top down from big size to smaller size, and from small size to a desired, that is molecule to molecule, bottom up approaches. So in a bottom up approach, the atoms or molecules, then we can go to a nanoparticle size, and from bulk to a nanoparticle. So in a top down approach, chemical etching is there, then laser ablation, laser or you can mechanical milling or ball milling, sputtering, electro explosion. Then in a bottom up approach, chemical vapor deposition, as I already spoke, laser pyrolysis and etc. And third approach, that is a green synthesis, in which, as I told you, that some part of the plant that has been used, like leaves, root, flower, fruits, then microorganism can also be used for synthesis. So the detail of the physical and the chemical method I'll be explaining in my another video, that is a part 2. So thank you very much. So here I can stop, and don't forget to watch my another video wherein I am explaining the synthesis of nanomaterial, and in subsequent videos I'll be explaining about the application of nanomaterial and different kind of the materials. Thank you. Please like it.